I'm CK. Tonight we've got a small module from Thing Modular, their startup. It's a mixer, headphone jack, and a clock source all in one. It's, in their words, designed to start a small portable rack or a small rack installation. It's a relatively simple kit. It's got surface mount, but it's all pre-installed, so I think we'll only be doing the mechanical bits. But it probably would be pretty useful. It'll be definitely useful for the workshop rack. So we'll put it together, see how it works, and I hope you enjoy the video. Here's the bag. Simple packaging. Again, got it from thonk.co.uk, where I get most of my modules. Let's see what we got inside. Paper bags, you always got to triple check you've got everything out of there. See, there are two, oh, those look like tap switches. That's probably for the setting the clock time. Put that away for recycling. Startup PCB in here. Startup panel is right here. Here's the bits. Yeah, it looks like it's pretty much the jacks, some LEDs. Oh, they include some knurlies to include it in the board. That's nice. And yeah, again, these are probably tap switches to do timing. But let's open up the PCB. I mean, not the PCB. The front panel first. Take a look at it. Get it open. It's fiber, or is that aluminum? Tooth test says it's aluminum. And we've got tap, diviply, which you hold to divide. So it looks like we can divide the clock signal in a variety of ways. And then there's a switch here for, I'm actually not sure. These holes are interestingly sized. I think these are, okay, so I bet this is these two are out jacks, and these are the buttons to get the input into it. Then left, stereo, these are the mix, and headphone jack, and startup word. And it's in an anti-static bag, the PCB is, probably because it's got a board with the surface mount components. And again, where did my scissors walk off to? I'll be back in a second. Scissors were over on one of my other workbenches. But they should go right here. That's where they belong. Okay, so let's pull this out. And there's more tape, and it's anti-static tape, even, it says. Who knew they made such a thing? Who knew I was so bad at removing tape? Tape didn't seem to leave any residue, which is good. And on the board we've got a couple of caps, a couple of resistors, oh no, diodes, some ICs, and then a red thing with a dot on it, probably custom program. Let me see if I can read these. They're part numbers I don't recognize. I might look them up later, I might not. And we'll dump out the board, the components in the bag. Power cable, of course. Input and output jacks. These should be stereo. The green one should be stereo jacks. That's typically what green jacks are. And in here we've got one LED, the knurlies and some panel nuts, and we've got one pot. Oh, it's a big pot. Six leg pot, 6-pin pot. So that's it. So this is going to go together pretty quickly. So I'll get the soldering iron heated up, see if they've got a build guide for this, and we'll dive into it. Now the first thing we're going to do, they have a good build guide by the way, lots of pictures showing how things work and all that. And let me just read through what this actually does, because I was a little vague on it. 5-channel output mixer, headphone amp, tap tempo clock, second channel giving divided or multiplied clocks. And the mixer has no knobs. Relative volumes are set by patching. The top row of inputs are loudest, second row are quieter, and the single mono input on the third row is quieter still. So you mix by adjusting patch cables. Now the first thing they would like us to do is put the power cable on. Oh, one other thing. I'm sorry for jumping around like that. Right here, there are 5 pads, and it's got a label. Thank you, Daniel Spilker. I think that's how you pronounce that. These are apparently, they go right to the chip here. This is for programming the chip with the red dot. So we're going to do the power connector first, and one reason for that is because we're going to power this up almost immediately to see, to ensure that the controller is programmed correctly. So did I get that all straight and good? No, it's a little high. Let me squish it down again. There we go. So we're going to be soldering this connector on, and then immediately going to be powering it up. Gosh, this board is a little finicky with solder. So that's that, and what we're going to do now is we're going to take our power cord and plug it in with the red stripe at the proper location. Good indicator on the board of where the red stripe should be. So we'll push that on home. I've got my floating shop Routemaster power supply that we'll plug it into. I don't have the power supply plugged in yet, by the way. That's why the LEDs aren't on. And we're going to take the red LED from the bag, and we are not going to solder it onto anything yet. We're going to go on the control side of the board, and I got to get something to weigh this down a little bit. Let me put these pieces there. We're going to go to the, let me look at the diagram to make sure I get it right. We're going to go to the divide section and see if we can get the, we're going to be checking the, I think I can spring tension that in there. Yeah, we're going to be checking to make sure it's programmed right. So if it's programmed correctly, that LED should flash when we, or should blink when it comes up. So let's plug the Routemaster in, and it's on. I don't see it blinking though. And again, I do not see it flashing. It is on. I'm going to turn this light off just for a second here. It's on, but I don't see it blinking. Let me try the pulse side. Oh, there we go. It's blinking. So that the module microcontroller is programmed appropriately. Let me go back over here and make sure, see if the divider is blinking or I just missed it. No, yeah, I'm missing it because it's not conducting real well. But I got a good steady pulse on this one, so we'll go ahead. Unplug the route master, unplug the power cable from the board, watch the route master, and of course don't put my fingers underneath it because you can see, even though it's unplugged, the LEDs are still glowing. These caps hold a lot of power, so be careful when you're, I'll put it this way, be more careful with things like this than I am. Okay, we're going to go ahead and put all the components on the board now. So yeah, this could be a very, very quick project. And we'll do the potentiometer first. Make sure we got all 6 legs in there. They went in fine. And we'll get the support legs through their holes. That all looks good. I want to take a look at this again. Yeah, okay. So that'll go like that. Okay. Now this is where you want to be careful. And all 3 lower jacks are the green stereo ones, and as you can see here, their outline on the PCB has cross-hatching, so you won't get it wrong, because you don't want to put mono plugs in stereo holes and vice versa. But this board makes it pretty simple to know where things need to go. Oops, leg is bent a little bit. And I'm making sure all the panel nuts are off. Nothing worse than putting jacks on, putting the panel on, and then saying, oh gosh darn it, I forgot. There was a jack. Hold on, I'm taking more panel nuts off. I'll speed the video up. Now we'll put the 2 tap buttons on. They're keyed, so you can't get them wrong. Yep, they have a good feel to them. Now we'll drop the LED in its location. And now, get the front panel and drop it on. And this is a pretty simple drop. The only thing that is squishing around are the tap buttons. Did I leave a... There we go. It all looks good. I'm going to get my silicone covered locking pliers for a second. And what I like to do, you don't have to do this, but what I like to do is I like to solder 1 pin on that component, that jack, and then 1 pin, let me get the tweezers back off, 1 pin on this jack down here, diagonally opposite that one. Make sure they're both actually flat. Then I will take panel nut and put it on one of them. And just finger tight for right now. And do the same down here. And everything's in place. I mean, everything's held in place. Nothing's going to be flopping around. We do want to make sure we get these push-to-tap switches all the way down. So I'm all the way flush on the board, I mean. So I'm actually going to do that right now. Same thing as I just did with the jacks. Pick the solder up. Just press the button down. Solder one leg, good. It's not going anywhere. Same thing again. Press it firmly with my pinky underneath the board. Solder one leg. Let the solder cool. And then we're good. And the LED, interesting. The LED sticks out quite a bit. I don't know if I want it to. I think I'm going to want it because I'm going to be, when I'm using this, I'm going to be pushing these buttons a lot. Hold for mode, hold for divide, tap tempo, all that. This being all the way out is almost a little bit in the way. So what I'm going to do is I'm going to bring it back so it's flush with the surface. I'm going to get a little piece of painter's tape, 7-day tape, whatever you want to call it, and put it across here. And then I'm going to, kind of going out of sequence here. I normally would do the LED last, but because of what I'm doing, to flush mount it to the front of the panel, I'll get it soldered on the board now. I'll also get it soldered on the board now so I can clip off the leads, because they're the only leads here. Take the tape off, and there it is. It's flush with the front of the board. Now I'm going to be doing a whole lot of soldering on all these jacks and otherwise, and I'll use this side of the board so the potentiometer knob goes into one of my holes that I built into this thing. Now, I'm going to do all these legs. One thing you got to be very careful about. There's SMD components all over the place, and you've got to maintain good soldering iron control. So you don't want to brush against the SMD components, you don't want to heat them up, you don't want to get extra solder on them. These can come loose pretty easily if you're a little careless with your iron. So use a small tip and just be careful. Keep your eye on where the SMD components are. And don't brush them, don't bang them. And the main reason for that, I mean, obviously the main reason is so they actually work, but you got to be careful because you may not see it. If an SMD component, a resistor or capacitor, comes loose, you might not even notice it. It might get lifted up, or it might get lifted up or moved, and you don't see it. And then when you're turning the product on and it doesn't work and you're looking at the back of the board to see if everything's soldered, you might not notice. So just be very, very careful. This would need a little more solder here. And that, lads and lassies, is that. I'm going to get my little index card out, make sure I soldered all the components, make sure all the solder joints are good. But again, that took, besides talking and messing about, that took about 15 minutes. So certainly not a complex board. I'm going to go ahead and put all the panel nuts on, and we'll speed up for that. Now we'll do the hardest thing for me, which is getting the index mark on the knob somewhat coherent. I think that'll be about right. Push that on. Yeah, that's pretty good. Get the power cable again. Ah. Come on. And that's it. There's the front. Buttons work smoothly. Knob turns well. Side. The back. Other side. Top. And bottom. Well, let's go ahead and put it in the rack and see what it does. Okay, let's get this thing fired up. There we go. We've got some pulses going. And let me get my pointer. Sorry for stepping in front of the camera. So we've got a bunch of wires hanging out, of course. I'm going to take the regular time signal to one of my more VCA's slots for oscillator, my even VCO, and the other I'm going to use the clock division to go to my other VCA, which will go to the Edu VCO, and that's going to be fed. I've got it mixed right now to the even VCO being louder than the other VCO. Now output, it's either to headphones, there are two headphone jacks, but one headphone jack is also line out. Now they do mention that there's only 1 amp going to these, so different combination of headsets and so on could cause different results that you'd have to play around with. So I'm going to turn this up a little bit, and turn this up a little bit. And you can hear it. Let me extend these a little bit. So you can hear them clicking away. I'm going to change this VCO to be slightly lower tone. And as you can tell, you can barely hear that one. I'm going to crank up the... Now you can hear it beeping a little bit. Let me create the bigger divisions. Now you can hear it a little more. Let me take this one all the way down. See the way they're alternating? Sorry, I just changed notes with the keyboard. That was a mistake. Well, I don't know what the heck just happened there. There we go. Took that back out. Now I've got the other one running at another clock div cycle. Now one more, and I can press and hold this, and it goes back to that. Now let me do a tap tempo, and you'll see the div goes crazy. Now I'll go real slow on the tap. And this, of course, works very fine as a amplifier. Now I'm going to switch these, the mix. This is the only way. Again, there are no knobs for mix control. It's just the top one is louder than the next one down and so on. Now you can hear that this one is definitely louder. I'm going to take this down one more. Now you can barely hear this one. I'm going to take this down. So that's what it does. It's pretty useful. It's good clock signals. I didn't do the stereo side of this because I never do stereo in eurorack. But as we saw, the build is very simple. I would definitely recommend it for a beginner, except for watching out for banging your soldering iron against the surface mount components. But other than that, works fine. It's a useful little unit. I'll have it out here in the studio rack, workshop rack, to give me a good clock, because I've been using my sequencer for that, but this will be better for a good clock. So that's it. Inexpensive, easy to put together, and useful. Hope you enjoyed the video.